In this video, we are going to talk about expansion of gases. In the previous video, we have already discussed about expansion of solids and liquids. Now here, the point you should note is, the first point you should note is, there is no coefficient of expansion for gases, because the volume of a gas is as a function of temperature, absolute temperature in Kelvin, pressure, and number of mole, meaning the volume of a given gas is going to change as you change temperature, pressure, and number of mole. So now let us see how the volume of a gas is changing with each of these variables. So according to Charles' law, the volume of a gas is directly proportional to the absolute temperature. The temperature must be in Kelvin. So, this means the volume divided by the temperature must be a constant, but the pressure, this case, pressure and the number of mole is fixed, is not changing. These are fixed. So, this time you have expression for the Charles law, V1 over T1 is equal to volume 2 over temperature 2. So this is Charles' law in equation form. Remember, this ratio is because the volume of a gas increases as you increase temperature, and the volume of a gas decreases as you decrease temperature. So the volume of a gas is directly proportional to temperature. If two variables, x and y are directly proportional, then the constant is always, y over x is a constant. This time the temperature is independent variable and the volume is dependent on the temperature. Let us do the second case. According to the second law called Boyle's law, so we can see the volume of a gas is inversely proportional to pressure if number of mole is constant and temperature is constant. So if keeping the constant temperature and a fixed amount of gas, the number of mole is constant, then as you increase the pressure, the volume decreases. You can consider a balloon. As you press it, the volume decreases, and as you decrease the pressure, the volume increases. So this time volume and pressure are inversely proportional, meaning the product of volume and pressure must be a constant. Now this holds if and only if the number of mole and temperature are not changing. So you can have volume in the first case and pressure in the first case is the same as volume in the second case times pressure in the second case. So this is Boyle's law. Okay, this one is Charles' law. Good. Now the other variable is, before we go to the other variable, there's another thing called combined gas law. Combined gas law combines Boyle's law and Charles' law, meaning this time the volume of a gas is directly proportional to temperature and the volume of a gas is inversely proportional to pressure for number of mole constant. Remember, combined gas law works for the number of a constant number, for a constant amount of substance, or for a constant number of mole. So this time you can have the conclusion: volume must be proportional to the product of these two, temperature times 1 over pressure, meaning this implies volume is proportional to volume is proportional to the product of this temperature and 1 over T. You can put 1 here, and so volume is proportional to T over P. All right, this means you can have V over T over P must be constant. This means V over 1 times P over T must be the constant. So this means Vp over T is constant. The implication is V, the first one case, and pressure in the same case divided by temperature in one case, absolute temperature in one case, is equal to volume the second case times pressure in the second case divided by the temperature on the second case. This is combined gas law. All right, now let's introduce the other one. According to Avogadro's law, what do we have? So according to Avogadro's law, the volume of a gas is proportional to number of mole if P is constant and temperature is again constant, meaning volume of one case over number of mole of one case is equal to volume of the second case divided by number of mole on some other second case. So this is Avogadro's law. Let's combine this all, Avogadro's law, to have expression for the universal ideal gas equation. So volume is directly proportional to temperature, Charles' law. Volume is inversely proportional to pressure, Boyle's law. And volume is directly proportional to number of mole, Avogadro's law. Now the same volume has this relationship. So simply we can put volume is proportional to the temperature times the 1 over P times the number of mole. Meaning the volume must be proportional to temperature in Kelvin times number of mole divided by pressure. All right. Now this is equal to what? This implies the volume divided by the volume over 1 divided by temperature times number of mole divided by the pressure must be constant. Okay, this must be constant. This means volume over 1 times pressure over temperature times number of mole must be constant. This means V times pressure over T times N must be a constant. This constant is called universal ideal gas constant, denoted by R. So V times P over temperature in Kelvin times number of mole is equal to the universal ideal gas constant R. Now you can put 1 here and crisscross. Then you're gonna have volume times pressure is equal to universal gas constant temperature times temperature times number of mole. So what do we have here? Pressure, divide both sides by pressure. Volume is equal to temperature times number of mole times universal gas constant divided by P. Now look, the volume of a gas, of temperature, of number of mole, of pressure, the function is changing with these 3 variables, is equal to temperature times number of mole times the universal gas constant divided by P. The universal gas constant R is calculated from these things, this volume times pressure divided by temperature times N, by considering the values of volume, pressure, temperature, and the number of mole at STP, standard temperature and pressure. At STP, at standard temperature pressure, so the value of temperature is 273.15 Kelvin, yeah? And the volume of a gas at STP is, the volume of a gas is 22.414 liters. And the pressure at STP is 1 atmosphere. 1 atmosphere of pressure means this is 101.3 kilopascal or Newton per meter square. So this is the value of pressure at standard temperature and pressure. So to get the value of R, you use the volume 22.414 liter times 10 to the power of minus 3 times the atmosphere, the pressure, okay, times the pressure. All right, the value of R is 22.41 for volume, because when you derive for R, you have R is equal to volume times pressure divided by temperature times number of mole. So for volume, we take 22.414 times 10 to the power of minus 3 meter cube, and the pressure is 101.3 kilopascal, means 101.3 times 10 to the power of 3 Newton per meter square is the unit for Pascal. So here is Kelvin at STP, and here is you have mole. Okay, so when you do this, the constant is 8.314. 8.314. The unit is liter. You can use liter, kilopascal per Kelvin mole, or you can use, usually it is represented as joule per mole Kelvin. So this is the constant. Now we have the universal gas equation, which is the volume of a gas is equal to temperature temperature times number of mole times, or you can say RTN over P. This is how the volume of a gas is changing. As we have already mentioned above, the volume of a gas as a function of temperature in Kelvin, pressure, and the number of mole is given by R, universal gas constant, R times temperature in Kelvin times number of mole divided by the pressure. This is the universal gas equation, the ideal gas equation. Thank you for watching.